Yeah, welcome to Coffee Compiler Club. In theory, here to talk about compilers and language runtimes and the like. And in practice, I'm still getting my head out of Burning Man and I'm trying to get back in the swing of things and go figure out how to write modern C++ instead of the stuff I wrote when I was writing C++ 20 years ago. And ever recorded? You show up on YouTube in a few hours. I don't have any set agenda. I kind of have a set agenda this time around. Um, that's it. Let's do the thing.
C++, you said the magic words.
Yeah, well, modular is all C++, or it's, yeah, mostly C++. It's an integration with Python and stuff. It's mostly C++. But it's like a modern variant of C++. And then I can go down the winding path of why modern C++ sucks compared to what I used 25 years ago. But that doesn't like help anybody. It's like no forward progress.
When you when you say variant, is it something other than like standard C++ or just it's not 1980s C++?
Right, right. And it was early 2000s, late 1990s, early 2000s C++. There wasn't anything in 1980s. I was fucking
Okay.
using Cfront in 1997, 1998. But
Sorry.
when I
Yeah,
say C++,
that was a bit much. I should have gone with 90s.
yeah, exactly. That's what I'm saying here. Yeah, everyone, notice I can tell everyone codes in a subset of C++. There's just too much language. Any given development team picks some subset they're living with.
Cliff,
Fine.
Cliff, Cliff. You're just getting started on meeting C++ 11. 26 is another big jump, and that's coming in a few months.
I haven't, I mean, just whatever goes on at modular is what it is. I don't make any claims as to what variant or level it is. It's certainly nothing like what I was using, in the 2000s. Um,
Well, since 2020, they had the require keyword. I'm, I didn't say that wrong. You got to type in requires twice.
Get over here and come up or stop yelling at me. The cat is not starving to death, by the way. He misses Lisa. I am a poor substitute. I am not the mama. He's letting me know about it. Fine.
So has C++ performance caught up with Java yet?
Exactly. Near as I can tell, no, but it could just be because that's how it's being used. Like the language sort of encourages premature optimization and writing in these hyper thin wrapper layers. And in an optimized mode, the wrappers all disappear, but you can't debug because it's optimized, and maybe you get
And
good
and you also
performance.
can't further optimize, right? So you get
Yeah,
the early optimization and lose all the late stuff that Java does for you.
yeah, right. And then the other version of that is if you run it in debug mode, the hyper thin, onion wrapper thin layers are implemented as 1,000 calls. And so to get anything done, it's just the CPU drowns in 1,000 uninline calls, and performance of the debug mode is gruesomely bad, way worse than it was in the 2000s. So
Correct.
you're left with too slow to debug or optimized, but then no debug info. So it's like, oh come on, guys. And I'm not talking about modular here at all. I'm talking about C++. Like, guys, C++ committee, whoever you are, get your head out and figure out how to do this.
There's been a little bit of progress with this OG option. There is still more in GCC than claimed, but for the first time ever, claimed actually does something different with OG than it used to.
You mentioned that at maybe if you're doing Discord, right? You should probably put a link to that somewhere because that sounds interesting.
I'd never heard of this feature. Can you explain briefly?
It optimizes while disabling some of the aggressive optimizations to preserve more debugging information. In
Oh,
short,
when you said OG, I thought you meant some kind of feature, not like optimize debug. I
Like
think that's
dash capital O
and
G.
the, and the lowercase g. Yeah.
Yeah. So where's the link? Find me a link for this thing because this is like the obvious thing here.
It landed in release 21, so it's equivalent now to O1 with f extend variable liveness. So the variables
Hmm.
don't get optimized out. So you used to get this error if you try to print a variable, that variable has been optimized out. Now you should see it less often. There's also one more option with FG I'm gonna find it in a moment. I'm gonna paste this one. I shouldn't be
Yeah,
looking up the things.
throw it in
Throw this in
the
the chat because I'm not opening Google Docs at the same time. Too many windows. Sorry.
gotcha,
Someone can put
gotcha.
this if they want to.
Right, right, right. This is a thing that I'm actually likely to directly use sort of right away. Um, I'd forgotten you mentioned it because I had too many things going on in my life here, but
And
yeah.
one more, that's gonna be set that by default now, but this only just landed. I got this from LLVM Weekly, by the way, which I highly recommend to anyone trying to keep up with LLVM. There is an option called the G key instructions. Now that's going to be on by default, but you can turn it on yourself and it should improve stepping behavior. So if you had this thing when you would be stepping suddenly backwards, upward, or skipping over things, that should get better with this option. We can just add it to Clang.
Let me see.
I believe I saw a lot of these flags in the GCC PDF, and
Huh.
Clang copies it.
Yeah, GCC implemented OG much earlier, and they had done a lot more work to be fair. Yes.
There we go. So I'm catching up on other things here. There we go.
This could be solved kind of on the library side if there was only something that says that inline even at O0, a lot of those wrappers would disappear. But that's manual effort, I'm afraid.
I'm going to have to give that a shot, see how that works. That sounds good.
Besides compile times, what's the worst part that you're having right now about the new syntax?
Oh, it's not the syntax, although I'm still a little catching up on some. Mostly the syntax is it's coming back pretty quick. No, it was the whole can't debug. Here's a new code base of 500,000 lines. You can't debug it and go do something. Okay, I want to add like a little stupid whatever. I want a command line flag so I can turn it on and off. The command line flag goes to some giant soupy sea of command line processing that eventually feeds into LLVM's soupy sea of command line processing, all of which you can't debug. And then your command line option gets thrown away. And you don't ever see it again when you come later to where you think you should have it, it's not there. So now go debug what happened to your command line option. This is like the starting of the start, like you
In
can't even get off the starting line kind
in
of thing.
LLVM, there is this CLOPT type, which you are probably using if you are using LLVM, that allows you to register options fairly easily. You just add a variable wherever
Right.
all of the other variables are in modular code base. It's probably different for you. And
Yeah.
then you should have new command line option. I
Right.
also recommend L debugging statements, LDBG.
Yeah. Okay, so no debug info. Okay, if I turned debug info on, then it was too slow. It was like minutes to get to where I believe my command line argument was getting tossed away by LLVM using probably the LLVM options. They decided that it was unused and would be thrown away. And I didn't know how to use it or declare that it was being used. I was using it, but LLVM thought I was not using it, so he's going to throw it away.
There's a couple of tricks, but I never need it because I have debug enabled, and I don't have to do that kind of optimization.
Well, like 10 minutes to get to, not 10, at least 5 to get to where it threw away my debug info, my command line flag. So
You figure that
that's what's kind of I fought for a while. I mean, I sorted it out, but as a developer experience, that was kind of brutal. And had nothing to do with, modular or the code base per se. It was the state of Clang.
compiler people would make the compiler debug experience decent.
I
Like they write the tools.
exactly. That's what blew my mind.
Yeah.
It's like, wait, what happened here, guys? As I said, I picked up. Okay, here's a flag I haven't seen before. Um, what is this a macro for? This is Matt on the
So
chat.
I pepper this all over the code for printf style debugging. It basically is going to tell you what file you are in, what is the name of the function, what is the line, and then it's gonna print your message.
Yeah,
So
you
it,
might not put that in the links, but move it down into the code blocks. But right, okay. So
that's
what
pretty
you just said
useful.
we're using printf debugging as a default debugging method instead of whipping it up in IntelliJ's debugger or LDB or whatever, right? And that was
Yep.
part and parcel of the issue was where's the debugging experience? I'm coming from I'm coming from IntelliJ, but I've used some other ones that were not IntelliJ, and you had this similar debugging experience. And then I get to hear, no, by default we're using printf debugging, and I'm like, you're using printf debugging? Wait, what happened to the debugger?
To be to be fair, this print stuff is a little bit controlled because this is going to only show up for a particular pass. You can select which passes you want to print stuff out of. You can also select to print after a transformation or print before, after transformation, or after each and every pass.
Yeah,
So there is
right. That's not what I'm saying.
control.
But yeah,
But yeah.
there's a hack here that does something useful. Okay, great. I'm like, but wait, why did you throw away the debugger?
But yeah, the debugging support itself could be better. For example, building with debug information creates much larger executables. And again, if you go to O0, they are really slow and,
Right.
and
So I've been
really
using
large.
O0 and not OG. I'm gonna have to try the OG or even the exploded out flags for that and see if I can get some better experiences going.
I just pasted my no opt function, so you could just toss that in. I use that for benchmarking usually.
Where is your no op function in
It's
the Google Docs?
it's at the bottom. Oh, someone just
Oh, it
copied it to the
just now
doc.
appeared. What's the
Yeah.
purpose of this guy?
So it basically it uses like a special keyword to say don't just assume this memory is being used for something, even though it's not.
Oh, this
Just
is
assume it is.
force keep alive so the optimizer doesn't get rid of some address, some memory for something
Yeah.
else.
Yeah, so whatever it has to be like an address of something, so you can't put a literal in there, but you don't really
Gotcha.
need to debug literals. Yeah. Yeah, so I use that all the time, and uh, actually, give me a moment. I just want to say it correctly.
Okay, so I had a little comment that you can feel free to correct me on, but basically keep something alive so it's convenient to go debug well optimized.
Uh,
Yeah, so as the size issue for debug info, I mean, C2 produces debug info, so well, okay, but it's because it's coming from a completely different direction. It produces sufficient debug info to get you back to the interpreter, and then from the interpreter you have, bytecodes which have a strong mapping to Java source, and then you debug that way. But C2's debug info then it's voluminous compared to the code, but nothing compared to what we get out of Dwarf.
It's much more sparse
Yeah, much
because
more.
we have both. We have both. We have it for save points, and we also have dwarf, and dwarf just has much more dense coverage.
Dwarfs the C2 debug info. Sorry. Yeah, right. It's much more sparse. So there's that too. I was thinking it just needed to have less info, but it's I didn't even think about that. But yeah, it's got to be 1,000 times less coverage points. And then within a coverage point, you just need enough to get back to the debugger, I mean to the interpreter.
when you originally said that you couldn't debug, I thought you meant like you can't see what the pointers are pointing to. Like, I
In
mean, it's
optimized mode,
just
yeah, that is correct.
okay, because I actually use a lot of pre-printers just to deal with that. Because
Yeah.
instead of using the standard vector or map and all that, I use my own. But then I got to write a pre-printer, so I did that. And now debugging is mostly a breeze.
Okay.
But my code base is not 1,000,000 lines or 500,000. So
Right. I don't have
oh,
pretty.
yeah, now I remember what I was going to say about the debugging. You can compile part of the file as debug if I remember correctly.
Yeah, I'm not up to that level of refinement, and maybe I need to get there. Like optimize all this stuff over here and debug mode that stuff over there, and get into where I
Well,
can
you don't.
run debug
I
mode on
don't necessarily
workspace.
think you have to separate it to different files. You can. I think you could just put like some kind of pragma, and you whatever function you're like writing or debugging, you would just like put a pragma about around it saying don't optimize this, and then you would have to rebuild and link that that one file or
Right. So there's a
whatever amount
large,
of files.
complicated build environment floating around Bazel.
You don't have to touch it. That's the thing.
Right, right. No, no. I like that. I'm trying to sort out how to go here. The build environment does all kinds of default things for you, and I can have a default, it's all debug, or have a default, it's all optimized. But a optimize here and debug there, it doesn't happen naturally. And so now I have to tear into the build system, figure out how to teach it, pick one from column A and one from column B. And what you're saying is instead throw down a pragma that says here, and then after every file I want to touch that way, which again, it's doable, go through and say, these files don't optimize so that I have a chance to go debug them when I'm staring at them. Maybe.
So that could be really useful to add to like um,
No, I have a much stronger, better answer. There should never be a debug flag. There should never be a debug mode. You should only ever run in full optimize and full debug mode, which is what Java's been doing for 25 years. Why the hell are you even bothering here?
well, you can't
You
because like
can't.
some optimizations
No.
absolutely wreck your debug representation.
Java's been doing it for 25 years. Full optimization and full debug at the same time.
Yes, but Java is also like 7 times slower than C++
No,
in
Java
some
is
cases.
as fast or faster in nearly every circumstance. Not all, but
No,
nearly every circumstance, it is as fast or faster.
The power of JITs.
The power of the JIT, you betcha.
It decompiles or what do you call it?
Decompile? You
Or not
mean
decompiles,
deoptimization?
deoptimized or
Deoptimize. Yeah. The secret there is that you have two execution strategies, the fast one and the slow one. The slow one can be debugged. The fast one's as fast as -02 or in that ballpark. And you have a way to flip between them, but you don't have to flip between them at every point. This is what Arthur was just saying, that the C2 debug place is much more sparse because every 1,000 bytecodes or so, give or take, you can flip between the two.
but
But if
there are plenty of situations, however, where Java is not nearly as fast as C++ and can't be made nearly as fast. For example, on ARM, we have, the memory model, right? So on x86, you get, implied like sequential consistency almost because of that like implied acrel in every load and store. On ARM, you don't have that.
right.
So if you start doing multi-threaded access to an array, Java has a bunch of synchronization overhead that's not there in C++.
That is not true. 100% not true.
Yeah, the Java's memory model is not the x86 memory model, except for all the people that run an x86 forever. I think it is.
Yeah. Java has its own memory model. In particular, anything to do with array access has nothing to do with the memory model, and it will do no serialization, ordering, or synchronization in and around array accesses at all.
I
But
think
it-
Ryan I think Ryan should try Cliff's CSV challenge.
Absolutely. Go beat Java on the stupid CSV challenge. The billion row challenge is a bigger version for which a bunch of people tried harder. And I will challenge you that you would have a really tough time beating the billion row challenge in C++. You should be able to get close to tying. Beating it, I challenge you. I think I'm willing to throw down some good money that you could not beat it.
Because
And that's because it does everything you would ever be able to do in assembly or C++ already.
I think
The winner last year, what language did it end up being in?
For
that was me.
For the
C++.
CSV challenge?
For the billion row challenge.
No, not me.
No, the billion row challenge is all Java. The end game was under a second for reading a billion rows. So he had to have no jitting, so he used crawl to pre-compile. So it's ahead of time compiled as one of the things because under a second, there's no time to jit. The fastest jitting one was under 2 seconds. And that started with no machine code. He just jitted as he went and got it under 2 seconds. But that would read a billion rows. So it's a 13 to 14 gigabyte file in under 2 seconds. And read it all and parse it and break it up into a billion cities and their temperatures and compute min, max, mean, standard deviation, blah, blah, blah. Bunch of modest math, but it's all about how to parse a billion rows of city names and ASCII numbers. The CSV challenge is the same thing. It's just a much simpler problem. It's an actual. I'd hand it to you, Ryan. Go take the CSV challenge. It's not very hard. I'll give you pre-running code for Java. It's go read only several, whatever, how the biggest one is some gigabytes, 2 or 3 gigabytes of data set that's from 70s era fintech log files. The lines are 1,000 odd bytes or something. There's 70 columns.
So
Go extract random columns out. Go parse this file. It's a CSV file. Go parse it. Pull some random data out. Do a join on the products that are being traded.
So what about cryptography though?
So anything that says I'm using custom x86 ops in the inner loop for all the kernels, Java won't directly do. So yeah, so if you're using any of the weird packed unpacked, the things that Java does JIT in the SIMD level ops, I left, it was doing, when I left, it was doing SIMDs or the basic things. I don't know, I know they've extended it. I don't know if they've caught up to like all the crypto things. So if you're using
Well, there
custom
are a bunch of
ops,
intrinsics. There are a bunch of crypto intrinsics in
oh, they are.
Hotspot.
Oh, cool.
Yeah, yeah.
Yeah, thank you. So
I know for a long time Java was falling behind on cryptography because they were doing everything 32-bit instead of 64-bit because they didn't have the unsigned 64. Has that been resolved?
I assume that's only a JIT thing. It makes no difference from the generated hardware, generated instructions. That's how you did the algorithm internally. That would be like we're using the big integer implementation used signed 32 bits because they wanted to do proper signage carry things. And I assume into 64, and I assume they needs a version of that that does 64 to whatever to 128 or something.
Yeah, I've wondered for a
Yeah,
while why Java didn't have an unsigned 64.
Because the model of the JVM says you have 64 bits and there's no extension after it. There's no larger size. So the infinite bits to the left of the last digit can be signed or unsigned and nothing else. It makes no difference. There's no code you can write that would verify that you were signed or unsigned. Prove to me, here's a 64-bit signed number. Here's a 64-bit unsigned number. Prove to me that they're different. It's the same 64 bits. They're bitwise identical. So you have to do something that does sign extension. Okay, the sign extension is an operation, not on the data. It's not the data itself, it's the operation. So you had to use different operations. Okay. What's an operation that does something different between signed and unsigned? Big multiplies, something. They're out there. But that has nothing to do with the data. It has to do with what operations. I need to unsigned 64
Right, but it was
to
the big
128
multiplies that was making RSA slow.
Yeah, no, I believe that.
The reason RSA was losing to C++ is because it was trying to do these 512-bit 1K, 2K, 4K multiplies. And
You mean the
that's
Java?
faster to do with 64-bit registers than 32-bit registers.
Okay. Yeah, I can believe that. I mean, this has nothing per se to do with the JIT or anything else. It was the library implementation.
Yeah.
So Ryan,
And
now
again,
where
you can
your
get aggressive about the JIT and say, hey, I've recognized the code path here is you're doing 64-bit multiplies using 32-bit registers. I'm just going to not.
Yeah, C2 picks up on some of that directly, but 20 years ago. So I assume they've hacked it more. What I want to hear from Ryan is where did you get 7x slower? That's like a ludicrous number. Like any casual testing will reveal that number is wrong by decades. Where'd you get 7x from?
It's
That was
amazing
in
the
the
number of bad tests that are out there.
no, that was an article. So someone had, let me see if I can find it. Um,
Do you remember what Cameron always says about this? That if you port C++ to Java, it gets slower, and if you port Java to C++, it gets slower?
Yeah, and I agree. The models are slightly different, and if you don't get the model to the language right, you'll pay.
That was a classic.
The other one is the second time you go implement something, you know a whole lot more about how the problem works and what's hard and what's easy. And the second implementations are often better, unless you go overboard and get too much shit, second system syndrome. But if you're just second implementation, you know how all things are. It's not a crappy, I didn't know what I was doing, so I kept making mistakes. And then I cleaned it up and it ran and I walked away without doing any tech that cleanup for version 1. Version 2 is, I'm not going to make these mistakes twice. And so it's just better second go around.
I'm rewriting Bold, and the second time I'm writing the LSPs, instead of, it probably is better, but it made me much
Modular
more
needs
annoyed and
LSP
angry.
features, by the way.
Pardon?
Modular needs LSP engineers, by the way.
Well,
We should talk
email
offline.
me. Yeah.
Fine.
Yes, that format is it just annoyed me so much, and it turned out that a lot of LSPs only use like seven of the 100. Like I think they have like 100 different requests and response and
Right.
notifications.
Right.
So and
You only
most
need
just
seven.
use seven.
Yeah.
It's just the autocompletes, the function signatures, go to definition, and like the basics. And
Right.
I'm like, I'm just gonna start with these, and it
So the
turned out,
claims I've heard as
yeah,
LSP is you can ignore all the ones that you don't care about. I don't know how true that is because I've never tried it.
I'm gonna try that. But I actually tried to generate a lot of the data structures, and it turns out the seven that everyone uses are the data structures that you can't generate. There's a lot of unions, and they have IDs as both integer and strings, and there's no C API because it's really annoying to write, and there's no official C API.
Hmm.
Wait, it dictates you what structures do you use? Wasn't just some APIs? Some you have to have these functions, these abilities. Why does it say which structures do you need?
I kind of missed part of the question, but for the API, they actually have like a JSON file to describe everything, and I've been using that to generate a lot of the data structures and the signatures and the big switch statements with like a pre-hashed thing, so I could use case because C++ doesn't allow strings in case. But I hope I partly answered that question. That's the
And
specs I look through.
use a hash, you have to have the perfect hash, which I guess maybe you can just do a
Yep.
perfect.
Well, I always double check by doing the actual string compare, but you only get one string compare because there's likely only one string that hits that hash.
Right. Why isn't? Nah, okay, fine. Never mind. Fine.
Yeah.
Sometimes you end up baking weird things into your JSON parsing. I had to interact with a project once where the rules were the number of the values could be either a integer in JSON or a string that started 0x and had the number in hex. And if you did 2 to the 53, you'd get a number. And if you did 2 to the 53 plus 1, you'd get a string.
Okay. Yeah.
And it was like,
Yeah,
you just had to write a special piece of logic that looked at that field and gave you an N64. And you were like, fine.
Right.
that's what I'm feeling right now. Yeah.
So when an LSP talks to, I mean, I've never written an LSP. When it talks to the language piece or whatever, he asks for position. How does he represent position? Is it like file, line number, character offset, or is it some sort of abstract syntax tree? Like what's a
Since
descriptor at?
since it was made by Microsoft, they use UTF-16. So I have to convert all my UTF-8 addresses to US. I actually keep track of the code points. So not UTF-8, just the code points, and then also the UTF-16 because I know I need to interact with the LSP. So what they do is they have a couple calls like did open, did save, did change, and did close. So basically, there's no cursor position, but they'll say did change, and then they'll tell you the line, the UTF-16 column, and then how much they deleted and how much they inserted.
Okay. I found the paper, but there is one thing to note is that they are trying to benchmark idiomatic C++ versus idiomatic Java, not like optimized Java versus optimized C++.
When you say idiomatic, or
Yeah, idiomatic, whatever you want to call it.
some weird version thereof.
So they're using basically like standard library containers and stuff like that, not like hyper optimized custom data structures.
Yeah. Okay. You can certainly shoot yourself in the foot in Java as easily as you can shoot yourself in the foot in any language.
I think they're making the point here that the C++ containers are pretty fast, and also like just the standard libraries is well does
Okay.
a good job compared to whatever Java has.
Yeah. The Java containers typically always carry a level of indirection unless they're just containing ints or longs to longs. Like I have versions of Java containers that do just longs, and you can bit pack within a longs to your heart content, but you
I
can't
think
do a
this
struct breakdown.
this is one of the fundamental differences that in C++ you can have more densely packed data structures,
Yeah,
and it might matter in some cases.
yeah.
Also, I don't know how they measure it in that article. As you said, you can shoot yourself in the foot in different ways with benchmarking. If you, I don't know, do one iteration and expect to see good performance,
Oh,
yeah, C++
gee.
will win.
And I see the paper says things about Scala, which immediately adds a giant overhead.
Well, they're actually comparing several different languages, but Java is one of them.
What this paper is saying loop recognition? What does this to do with speed of anything?
It's,
Like, surely he's not talking about C2 doing loop recognition in this paper because he has no visibility in what he's doing.
I don't know if it was talking about Growl or
Now, he's got to be talking about using an implementation. I'm guessing. I'm just whipping through the paper at high speed and skimming. Like he's doing some sort of, I'm trying to do something about the language or discover something about something written in the language. So it's not C2 at all. It's I wrote Java to go do something. In my particular implementation, I have a speed up or slow down of some factor over whatever. But that just tells me that he uses a poor choice of library function implementations for the job at hand in the Java version.
so
And
you
I
just
argue for Scala. So Scala 3 is another whole ball game because it,
I don't think he's writing it in Scala. He's
Oh,
writing.
the loop recognition is because he actually implements the loop recognition algorithm. So
Hmm.
that's the benchmark. The Tarjan's loop
Ryan,
recognition algorithm is actually what is being
hang
implemented.
on. We're gonna fix an audio issue here. Ryan, would you mute your mic when you're not talking? Because I'm hearing the feedback as well. And it cleared up. Okay, so we get a little feedback from you, Ryan. So it just means, unmute when you're not talking. You're free to talk, just unmute when you're not talking. Or mute when you're not talking. Blah. Fine. Okay, go back to our regularly scheduled. What the hell is it? Matt, you were saying something and I cut you off.
So what I was saying is that the loop recognition is because that's the benchmark. That's what the paper is implementing, the Tarjan's loop recognition algorithm from what I can ascertain.
Gotcha. And they're implementing it in these different languages and they're asking how fast are they and all that. I certainly do loop recognition in Java. I challenge it would be as fast as anyone else's because how I'm set up, I know that it's not going to do anything that I wouldn't have done in C. That being said, I'm not necessarily writing it in the way he's doing and however way he's writing it, so fine. Okay, so he has an implementation. And this is Robert Hunt too. He's like a reasonable guy. What the hell is he doing here? And
I
nothing to
think
do
there
with.
is something to be said, though, for talking about languages by which idioms the culture of that language reaches for.
Yeah, no, that's
Because
fair.
the idiom of JavaScript is string.split.
Right.
The idiom in Java is string.split.
I never do string split in Java. Like I dodge that one like hugely. So maybe that's because of my history.
You know, that
Uh,
was one of the jokes about Ponylang, was that the code was much faster and more efficient in that language because there were just very few people who weren't high-speed traders using it. The
Wait,
disadvantage is that libraries were tiny and unavailable, so you had to write the logic yourself, and the advantage was the logic you wrote yourself tended to match your style quite well.
Yep. Right.
are you talking about OCaml?
No, there was a language called Pony, which I only know
Pony.
about because they had an interesting ownership type system
Right.
that
Oh,
they claimed allowed you to write much faster code because you could do much cheaper ownership
The ownership was
calculations.
specific for multi-threading as opposed to lifetime management. I think I did both, but the multi-threading version looked very interesting.
But when you talk to them, you realize a lot of the reason that their language was so fast was the idioms of the language was a bunch of people who got together and made a language who all really cared about the nanoseconds.
Right. Yeah.
You know, I don't know how fast you can write code in Python, but if you're really trying to write super high performance Python, you've just rolled out most of the libraries in the world because the libraries were not written under the assumption that you cared about performance a lot.
Right, right. So he's picked up performance hacks from, okay. So among other things in the paper, he's allowed a bunch of other engineers to pile in on his particular benchmark for C and C++, and they picked up a bunch of speed factors from that. I would claim that the same effort applied to Java would produce the same results, but that effort was not done, at least in this paper, at least not reported in the paper. So I'm curious to see. It's like the CSV challenge. I did a first cut using string split, and I knew it would be bad, and I said so. And then I went through and got rid of the string split, and suddenly I get down to numbers that look like. And then I ran it in C. I have C code for the CSV challenge as well, C++ actually. And C++ loses to Java quite handily until you get rid of all the accidental allocations that come along. Same as Java, though. See, Java, if you do accidental allocations, and string split is a giant problem there with accidental allocations. If you allocate while doing the core work, you lose.
That's actually kind of an interesting topic, is how slow GNU's allocator is, because like fundamentally,
No,
allocating memory is not something that needs to be expensive.
it's not.
Right.
It is not the active allocation. So Java allocating is a bump pointer, and it's a L1 cache hit, highly predictable load compare branch. That's not the cost. The cost is since you allocated, you got some memory that was not in your cache, and you ran out of memory bandwidth doing endless not in cache allocations. Same for C++. Assume that the allocator cost to get a pointer that is valid memory is 1 clock cycle. Just pretend that it is. You would still suck if you allocated. It is not the active allocation.
Well, that's why you have a thread pool that has a like a stack essentially. You free and you push on the stack, and then you allocate, you pop from the stack, and then it should be cache local. Assuming
You have to deallocate. You have to do lifetime tracking. If you do lifetime tracking in both Java and C++, you get to the good numbers. And if you don't, you lose. And so you have to do lifetime tracking. And suddenly the GC advantage for Java goes away because you're doing lifetime tracking. Okay. But it also goes away for C++ because you have to do lifetime tracking.
Well, I'm just saying, like, you just pop the most recently allocated thing of a given size.
Yeah.
So that's possible to do, but it doesn't fit the C++ allocator model very well. Which
Just
is the
saying
unfortunate thing.
that is the kind of thinking that has to happen to make at least the CSV challenge go fast. It's not a hard challenge to make it go fast, but you have to stop and say, hey, once per line, I'm done with a line, and I'm going to reclaim that storage. And because I only have one at a time, I don't have to do what you just said, which is to say, make a stack of them. The stack is one deep. I just have a free thing. And so, because it's just the one guy, I just recycle it. As soon as you get to that mode, oh, your speed comes right back. But you have to think about it. And if you don't do it, you lose. So the billion row challenge has that in spades, except you also throw down concurrency, for which Java is really easy and really convenient to throw down concurrency. And then you parallel parse the giant WAD and all that kind of things. You do all the games, mem mapped, everything.
So one of the things I was planning to do for my language, whenever I finish it, is that basically when you allocate things, in C++, you just pass the size in as like a runtime parameter. But what I wanted to do is make that a compile time template parameter, basically. So it'll automatically, you just go into the function and it knows which stack or whatever it's allocating or popping from. So there's no lookup that happens at runtime. It's just like, okay, I'm allocating this type of object which has this size and this alignment, and then that goes to a function that is already compiled specifically for that size and alignment. And so it already knows like where the global stack for that type of variable is, or like
This
what
is a
different that
thing that has
is.
been used on and off throughout history, and for the right programs, it works great.
Yeah, it's actually been done for security right now by Apple in their XNU implementation, because the reason is that you want to actually allocate different object types in different memories. So even if you have memory safety error, it's not gonna matter because you're just gonna be able to have some type confusion problems with that.
You're not doing it for size, for speed. You're doing it because secure things go
security.
here and unsecure things come out of that pool
Or
or
just
something like
different
that.
types go elsewhere. So
Yeah.
even if the attacker gets access to an out-of-bound memory and it's gonna try to get to the next object, well, the next object is gonna live entirely in a different area, so it's not gonna be that much of a problem.
Interesting. Okay.
Yeah, so my idea was more performance oriented, where every object of a given, I mean, obviously like some sizes would be bucketed together. Like if you have 4098 byte and 4096 byte, those, well, actually that's a bad
Yeah, that's a
example.
bad example.
4000
Oh, wait,
4096 bytes and
yeah. You round
4092
up
byte
to the nearest
objects.
bucket. Yeah.
Yeah, those are going in the same bucket. And then for like very, very large objects, I probably have like a just if it's bigger than this, go to the operating system kind of
Yeah.
allocator.
To be fair, that is to some extent what malloc is also doing for you. When you compare, of course, it's worth comparing different malloc implementations. Some of them play some very interesting tricks also for threat aware allocation, but they definitely do sizing, sorting by size.
Yeah.
That's one of the
Right,
most
but when you
common.
call so like here's a big problem with malloc, right? When I call free, it doesn't know what the size of the object is, and it's got to go take some offset against the pointer to
Yeah,
look up a structure that has the size in it. Whereas if what I'm doing is like if I have 16 byte objects and I always call the delete function with a size and an alignment, then there doesn't need to be a tag that says this is how big the object is. I can just have these objects packed 100% density inside the allocator pool.
Yeah.
So I've saved all this cache space, right?
This has been done
by the
before.
way, the standard also got that. There is a bunch of proposals. At least one is the sized deallocation for placement new, and the idea is that you exactly tell the
Well, no,
size of what is it that you are
I'm aware of
deallocating.
that. That actually I believe got standardized, but the problem with size deallocation is that it's a hint. Because it's not required. So if you do like if you allocate something in C++ and then you do size delete, right? That is a hint. It is not like you have to allocate something and then you have to be able to deallocate it normally, which means that size has to go somewhere.
I never cared because I never used malloc in a hot loop or new in a loop. So I don't care how
Pre-allocate.
slow it is.
Yeah, I'm not ever certain that your pre-allocate everything's ever going to work on the long-term big things because it's either using
Well,
too much when things are small or it won't be big enough when something gets big.
I don't actually pre-allocate anything. I just use the standard, like when you push to an array, double the size if it
Yeah.
reaches the end, and it never gave me a problem.
Oh, okay.
Yeah,
I
it
thought
never gave me a
you were
problem.
actually fixed size but large allocating things.
Nah.
At least
Well,
for
I'm in C++. I don't need to pre-allocate anything.
okay.
Oh,
Yeah,
by
so
the
what I hear you saying was it Ryan? Ryan is that this is like a size so the compiler can constant fold it. This
Yeah, and I guess technically malloc could do that too if it's
yeah.
inlined, but like that usually doesn't happen.
Yeah,
Like
that I don't know, but it seems reasonable for it to do so. But that's like, would you
I
inline a standard library call with constant arguments? Makes a lot of sense.
It doesn't though, because like if you there's like malloc hooks and stuff that it has to check if that's installed, and then so
Yeah,
that it
right.
basically doesn't get
Okay.
inlined.
Yeah, I don't
uh,
know.
I just want to add that I in the docs I added a piece of code that will de-optimize when you're compiling in both GCC and Clang, and I also gave and you can also see at the very bottom like the GDB and the LLDB line to like check that it's running correctly on your machine, so you can see the variable a is giving the proper values.
Oh, nice. So this is this flag set. This is the pragma in the code to force the test function to be debuggable in optimized builds.
Yeah,
Yeah, right.
that should work on both on all systems, but I only tried on my
Yeah,
Linux.
right. No,
That's what
I
I'm
have
on.
this giant thing I have to go sort through, but this is a nice start. And then replace -G-02 with -OG and see if I run fast enough and I can still debug it. But this is a good start.
Yeah, it's
Well,
not gonna work on that's not gonna work on MSVC. I think.
well, Clang and LLDB are on Windows as far as I know. But Cliff, you don't actually have to do a -OG. Okay. Well, it's very important that you have the -G in here.
Right.
But the OG is actually coming from the top of that code block. Do you see how there's a -OG on the
Yeah.
second line there?
Yeah.
Yeah, so you don't actually have to change anything in the build or the command line
Ah.
flags because it's in there. It's in the attribute. That attribute only works in GCC. I don't
Okay.
100%
Yeah. I'm,
know
I'm
what Clang does.
almost surely going to be stuck using Clang here.
Yeah, so I don't know how well it's going to work, like on Mac and
Yeah.
on Clang, but this is working. I just tested with this and it works. I confirmed it working.
Right.
This one working.
No, this is a thing. I'll go play with this. See if it's going to go.
What is
Yeah,
the
how close I can
attribute
get.
called? I don't recognize the _ attribute _ thing.
The pragma? This?
Well,
That's just how you give instructions to GCC.
Yeah, that's GCC's custom attribute thing. I'm not a
GCC and Clang.
Huh, today I learned.
Well,
Yeah.
just Clang did this? Is that you just said yes for Clang?
No, Clang doesn't support on this optimize, unfortunately. You have to use this first line, pragmat line optimize off.
Okay.
GCC actually supports a lot more in this. You can switch to different optimization levels, like O1, O2, or 3 per function. You cannot do that in Clang.
So GCC and Clang. Okay, Clang supports a lot of GCC stuff like attributes.
But not this one.
Yeah, not
Definitely
this
not
one.
this one.
Oh, I see. Okay.
I think attributes are part of the C and C++ standard now.
There
But
is,
not,
but it's a
but
different
not
syntax.
this one. Yeah, the double.
That talks a lot about
square
this piece
bracket.
of code. You not only have to deal with C++, and you have to deal with two different implementations of the C++. With
Some
Clang,
people even with 3, but I don't think that MSVC is that much used outside Windows nowadays.
So I mean, a lot of the GCC stuff, like if you do, I think it's like GCC : or something, or GNU. I don't remember, but like a lot of if you just use the standard attribute, you prefix it, it'll pass it through kind of the same stuff that you would use with the other syntax.
All
in
right.
Clang,
That's C++
Clang,
only, though.
if Clang sees the attribute, it will just keep it because it's not supported. It's not supported in Clang. You said only for GCC. If you pass that to Clang, it will just keep it.
It will just ignore it because basically it's the compilation model. It doesn't allow on the LLVM level to have different functions with different optimization levels. And it's non-trivial to implement this for Clang LLVM compilation pipeline.
I mean, you definitely can. So you can create optimization passes and
There's
then
been a very long discussion in LLVM discourse that is very much not. You definitely can't.
So
You
what
have
I
to
heard,
rewrite the entire LLVM optimization pipeline because many passes are module passes, and then write on the entire module. Module corresponds to a translation
okay.
unit.
So yeah, I'm thinking of running like different different
Inliner, for example.
Yeah, inlining is where this would be a problem, but like I definitely can like create an IR function, run a pass on it, and then link that into another one after I've done the optimization and run different passes on something else and then link them together.
Right. It's just right now as it is implemented, that would be you would have to change a lot of how pass pipeline works in LLVM, the existing one.
So basically what
Yeah.
I got from this is if I start writing something, I have to better choose a compiler. So GCC or Clang.
Or you just write a
Oh,
macro. There is actually even a library called Heavy that does compiler portable macros. It's really not a big deal. In every project, you can assign this to Inter. He's gonna use one day to write the macros, and it's problem solved. It's really not a big deal in practice. The problem is when you have compilers like NSVC that sometimes decide to implement attributes, even the standard attributes differently. Like there's this attribute you're supposed to have zero-sized allocation, which replaces the empty based optimization, and in the infinite wisdom, certain compilers decided not to implement this attribute.
Well, it does. I mean, technically speaking, they are compliant because it says that it removes the guarantee that you have a unique address. It doesn't guarantee
Yeah.
that the address is non-unique. It's just it removes the guarantee that it is unique. So
Which is
technically they're
kind of
compliant.
pointing out that maybe some of the attributes that can change the behavior of the program shouldn't have been an optional attribute, but they should have been language keywords that the compilers have to adhere to.
But
Because the problem with
the
this empty base optimizations, this is ABI. This is something you actually do want to rely on forever and
but
ever.
the ABI has never been part of the specification though, for C++ at
Well,
least.
in practice it is,
No,
because things like unique pointer cannot be changed because of ABI, things like
no.
standard unordered map
This has
cannot be
never
changed.
been the case. Even between GCC and Clang on Linux, there are types like there was a good example
Oh, we lost you, Ryan.
of this where they didn't agree on like what the type key was, where one of them would pass it in a register and the other one would pass it on the stack or something. Like there
Right.
are a lot of ABI disagreements
What
between
I'm saying
compiler
that in
platforms.
practice, proposals have been rejected, and the reason for the rejection was this would change ABI. So you can say that the standard doesn't express ABI in theory, which is true, but in practice, the way a WG21 standardization works, they do reject proposals
Well,
because
yes,
it would have
they
an
don't want to
ABI
break
impact.
the ABI. Like they don't want to force people to break their code, but they're so the standard
Ryan, we're having sound
something that
issues
forces
from
an
you.
Breaking
ABI
off a
break.
little bit,
ABI
yeah.
that's outside scope. How about now? Is that better?
Well, you've been cutting out for 3-4 seconds of time on and off, which
That's
sounds
weird.
like internet issues as opposed to like mic placement.
It's probably Wi-Fi interference, honestly.
Yep. Okay. Well, do we
I mean,
sort
that's
this
one of the
out more or
problems
less?
when you're trying to specify a language is you can decide which things you're willing to promise in your spec and which things you're not willing to promise in your spec and say, hey, my spec cares about API or it doesn't. But people will look at what you've done in the past. You know, I have that friend who always says no promises, but also always shows up on time. And you have that friend who says, no, I promise I'll be there on time and never shows up on time. The one you assume who's going to be on time is not necessarily
Yeah.
based on what they promised they were or weren't going to do. I
Right.
trust C++ not to break my already compiled things because they have a good track record of not doing that, whether they promise to do it or not.
I mean, that's more the compilers though. And like there's been 5 versions of the GNU ABI, right? So at least, and there's a flag that you can use to change which ABI you're using. And I think a
Five
lot of it,
versions in how many decades?
Yeah, exactly.
right, but also like part of it is an illusion that is like created by your distro because the distro says, okay, all programs that are in official repositories use this ABI and this compiler basically, right? Whereas when you start cross-compiling, you start realizing just how different it is in many cases, where one Linux distro uses this ABI and another one uses that. And if you try and if you manually compile something against the wrong compiler and ABI, like it doesn't work. And there's a lot of that, honestly. It's just hidden in Linux land because they can like centralize all the packages to a degree that doesn't happen on like Windows. Like I remember like compiling we back when I worked at Intercontinental Exchange, we like compiled something for Red Hat 8 and then tried to run it on Red Hat 7 and then it just crashed because of some ABI problem. So like it appears like they're compatible, but they're not in a lot of cases. Or like the compatibility goes one way, like you compile on Red Hat 7 and it works on Red Hat 8, but if you go the other way around, it doesn't work. Stuff like that.
All right. Yeah, there's
Do
a
we know
mess
what
there
happened
outside
at
that.
Microsoft that changed them to focus a lot on ABI stability? Because there was definitely early days when they would say the next version of Windows isn't done till Lotus Notes won't run. And now they're like, no, we want to be able to run all this old stuff all the way back to Vista without anything breaking.
Yes. I do remember the Lotus 8 yeah.
Well,
Oh
one thing
yeah,
I
people got
noticed,
super mad at IBM because Microsoft was deliberately breaking Lotus Notes with each update.
Yeah. Right.
The specifically on Windows, I remember there's like a library that I was compiling or downloading or something, and it had like 6 different DLLs for like one was like MSV with debug enabled iterators, and then one was like MSV without debug iterators, and then one was like GCC, and then one version was like another version of GCC that had like different options for compiling on Windows because like one of them used Sidewin or something, and the other one used like some other compatibility layer with
It's
Windows.
like
So
is that
there was 6 different binaries, basically 6 different DLLs for the same library that was compiled with different ABIs.
DLL hell. I don't know. Java has some of this fixed with it's all just class files and JITting, so there's no ABI. Although you get a different version of DLL hell, you get the Java class file hell version. But yeah,
Yeah, I've been trying to fix this in my language by just statically linking the entire binary, and then you don't have to worry about any of it.
yeah, yeah. I mean, maybe that's the way of the future. I don't know. That has
Did
the
you,
standard problem that you just get replications of giant standard shared libraries, which if machines all get bigger and bigger than standard libraries, no one cares.
Well, I've taken the approach that if the only situation where you're concerned about duplication is in embedded systems, and in those cases, you can probably just create one monolith and not have a bunch of separate binaries running
Yeah,
around.
yeah. Yeah, yeah, yeah. There's, I mean, there's places where it clearly matters, and maybe there are places where it clearly does not, and we should just give it up and walk away and say, just statically link. No one cares anymore.
Maybe there are like
Well,
routers and stuff.
I would say Electron apps, people running multiple Electron apps, all linking their own version of Chrome statically is just not the greatest efficient use of memory, especially on laptops.
So you're saying it's still a place and time for dynamic linking, which I can believe too.
the other day, actually, wait, I want to ask this first. Did Lotus ever like sue Microsoft or Microsoft get in this kind of trouble for like intentionally breaking other companies' software?
That was the days of the wars between
Yes, Microsoft has been sued for monopolistic behavior. It was a thing.
Oh,
But
that's right.
specifically for breaking Lotus, that's what I'm wondering.
Like it's my OS. I can do what I want with it. I made some change that I gave a reason for that happened to also break Lotus Notes. The reason could or could not be contrived, but I
Okay.
give you a reason that's not entirely ludicrous. Okay, what are you going to sue
Okay,
for?
I can see that.
Yeah,
Yeah.
why are you suing? What's the lawsuit?
All
Prove
right.
that I had evil intent.
So the other day I saw a couple of jokes about Emacs, and it reminded me that people considered Emacs bloated back in the day,
Oh,
kind of like
absolutely.
Electron
Yeah,
today. So I'm
yeah.
like, Emacs kind of reinvented, kind
Emacs
of.
had the acronym 8 MB and constantly swapping. Not
Yeah.
8 GB, no, 8 MB and constantly swapping. So that was the joke about Emacs back in the day.
Yeah. Right now, my binary size for bold is less than 2 megs, so
There you
feeling
go.
fine.
Right, right. I mean, there comes a point where some core base functionality, like say a JIT and the runtime supporting it, fits within some modest amount of memory that suddenly becomes small relative to the machines. So certainly when C2 first came out, it was considered a big chunk of the VM, but we could run spec whatever JVM 98, like really tiny stuff in 64 MB and get good scores. Well, these days that included the whole VM and the JIT and the runtime and the GC and everything in 64 megs and run the benchmark. Okay. These days, if you told me I had to download a 64 MB thing as a core base to go do whatever I'm going to do on my desktop, like I fucking don't care. It's just too small to like even bother. So you threw a JIT in the 64 megs. Okay, you did. Why do I care? It's too tiny, right? It has nothing to do with nothing. It's however you implemented your shit, you did. I don't care. So
I
there's
wonder how many layers of abstraction until things become like hundreds of megabytes or gigabytes.
Yeah.
So my VS Code instance that I'm running on my computer right now is using 120 megabytes of memory.
There you go. And how many gigs do you
The
have? So,
text
That's
files that
small.
I have open are not 120 megs.
Yeah.
right.
So much of that though is JavaScript and CSS and rendering frameworks, and I don't know why we've like traveled down this route of like using dynamic languages to do user interfaces. It's so slow. I mean, like compare the experience on Android, which usually does this, to iOS apps, which usually use Swift, which is a native compiled thing, and like the performance difference is so huge, it's ridiculous.
So what
I
I
wouldn't blame
noticed,
it on dynamic languages though. Look at some of the Tickle TK stuff. Like,
what I noticed is every 7 years, Microsoft launches a new UI framework, and they never succeed. And they've been doing it for at least 2 decades. So I think the reason why they patent in Chrome was because people actually use it, and it's not going to fail in 7 years. Silverlight people.
Yeah. I've
Yeah.
seen plenty of failed UI efforts, and then that's an interesting question. Why do UI efforts like yeah, you said Silverlight. Java had several things, right? Java FX and Swing, and like, why do these things fail as opposed to succeed? What's the thing that drives the market down to we're going to pick one of several small count of UI frameworks? Is it just too much pain in the neck to maintain or get a developer code base, a common count of developers who know how to use the UI tools in order to go make the 1 million apps? I
Well,
mean,
I think Electron had the advantage that they just had so many CSS and HTML and JavaScript programmers from web development that they could just piggyback on. But like
yeah.
the other successful stuff has been like Qt, and that Qt is super cross-platform. Like think of it this way: if I'm a developer, am I going to choose Microsoft Silverlight so that my code only runs on Windows, or am I going to choose Qt where it runs on Windows, Mac, and Linux?
But
But
it's
that
been
doesn't
Qt
explain
been
why
super popular?
that doesn't explain why the Java ones aren't
not
Yeah,
as
though.
popular as Silverlight was.
QT.
But
Okay.
I can suggest reasons for the Java ones. They're terrible.
Yes,
The
I'll agree
UI
with
quality
that.
that you produce is so bad, and they're slow as hell as well. So like the UIs are just slow.
Yeah.
Yeah,
And
but
but
there
actually
was an entire decade of swing.
Yeah, but it
I
was it looked ugly for me. It wasn't speed on Swing. It just looked uglier in Sin.
yeah,
So
I mean the
BG.
ugliness is bad, but it's also it if you actually tolerate the ugliness, you'll find how slow it is.
Okay.
Uh, and it's hard to be that ugly. So
You have to try hard to be that ugly.
you do. But
Okay.
Oh, I
they're
disagree. I've
actually
made UIs. I can do ugly quite naturally.
well, you
So
can
the
take it to another
answer is
level.
BG, I think.
But
Yes.
there's actually another UI framework that I found that just some one guy built. He built it, well, it's in the Clojure community, but it's running on the JVM. And it's actually mostly written in Java. So it just happens to be Clojure World, but it's a Java library. It's called Humble UI, and it makes really nice UIs. And I've made some beautiful UIs with it. It uses like the same rendering engine that Chrome uses, so it's like really
Hmm.
like it has every possible effect and everything, and typography is brilliant. The guy did a brilliant job, but nobody uses it, so he's sort of moved on. It's a bit of a shame. It's a huge shame, actually.
I
I
feel
used
like
it for a project like when he was in kind of early beta, and it worked great. It was just a little project of my own,
Hmm.
just a rant.
I
All the
do feel
failed good projects in the world. There are
there's
lots.
there's obviously like some different toolkits only work with certain languages, and so that also like influences it. Like if you have an amazing GUI library, but it only works with Haskell, you're not going to get that many people using it.
Yeah, well, this one was on the JVM. I mean, it's decent user base there, but
You have to
I
use
think
Clojure
people
to
have
make
sort
the
of
code.
written off JVM for front end UI just because of how terrible the old options used to be.
Right.
Yeah, I feel like it's mostly Qt for like cross-platform native UIs and a lot of Electron because it's easy. And then
I used
Electron's easy, but the
React.
apps that you end up with are not very good.
I used React and React Native for Android and laptop cross-platform.
Yeah.
Yeah, I think does React use Electron or
No, it's its own
oh,
thing. In my
interesting.
case, I needed the React Native on Android to pick up the camera for the QR code and to pick up Bluetooth and have Wi-Fi connectivity. So I needed a bunch of things sort of directly based on the phone's hardware. And then I wanted to have a common interface and a common write-up thing so the laptop side, which just had a bigger screen, could show more stuff, but it didn't have and wouldn't need the Bluetooth or the QR code or any of that stuff.
Yeah, I've seen a bit of WX widgets as well. And then on Linux, like GTK is super popular, but like if you're talking apps that run on Windows, almost nobody uses GTK because it looks so bad, honestly.
GTK? This is not Tickle
I built-
TCK, right?
G-
I
GIMP,
built a UI.
GIMP
I built a-
toolkit.
Well,
I built a nice UI app really quick, just vibe coded it in the early vibe code era using Dart and Flutter. And that is such a nice tool set. And it's simple and it works well and it produces really nice looking stuff. And it works all like phones, native apps, web apps, everything. It was pretty cool.
I
Yeah,
thought
Dart was
Flutter
always good
now,
tech with bad marketing.
okay, I thought Flutter was now dead. I thought Dart was pretty dead too.
I don't know. It might be dead, but it sure works well.
I mean, they're still around. They're not like abandoned projects as far as I know.
It's funny that Google did not kill it.
Okay. Because I went hunting before I picked up React Native. I looked at Angular, I looked at React. I want to say I looked at Flutter, and I hunted all the webs wide. And the various people said Flutter is kind of nice. It has some issues. It's been abandoned for a while. It's not keeping up. And
I
Angular
will
versus
say,
React was a little nicer and had better interactivity, better integration with the phone hardware.
one thing I've noticed about the successful UI toolkits is that they are a toolkit and not a I am everything and the kitchen sink, which a
Yeah.
lot of the like stuff that is failing, in my opinion, or fails, tends to try and do too much so that you have to like pull in like an entire framework and rewrite your app in a new language and like whereas like
That's true of React, definitely.
but the stuff that's been like long-term successful, which I feel is like Qt, and to a
The
certain
React's been
extent,
around a while.
I
I think
would
Qt has
say I would
too.
say Qt is definitely a framework, not a library. It
right,
even
but
had its own container types, and the compilation model was kind of extra, if you know what I mean.
but here's the thing though. I can just use the Qt widgets and I don't have to pull in the rest of Qt. That's the thing. Like it's really easy to just say, here's the UI part, and like I don't have to use the mock to use Qt. I don't have to use any of that stuff. I could just include it in my CMake project and use it like I would use any other library, and I don't have to like redo all my tooling. Whereas if I want to use Flutter, I basically have to go through, to my understanding, the whole Flutter system.
The Qt's still going strong.
It is
Okay.
still going strong. And like WX widgets, I feel is also like really popular for similar reasons.
I'm surprised we were talking about GUI this long.
Huh? You got
Angular
something else to talk
also
about?
You
also
wanna
Because it
try
matters.
compilers?
GUI matters for compilers and for language design. You know,
Yeah.
when I first learned BASIC, day one of being taught BASIC was here's hello world. You put text on the screen by calling print. Here's screens. You draw a box on the screen by saying start at this pixel and draw your line to this pixel. The pixels are defined by top and left.
Yeah.
And that was
And
literally my
pretty much-
first day of learning BASIC was draw a circle, a triangle, and a square on the screen.
And
Yeah.
pretty soon you would also say this is how I read the joystick being pressed, and
Yeah.
the fire button on the joystick being pressed, and here's how I make the sound. And it's
Right.
interesting to compare this today, where
On your first day of Python,
getting
you do not
sound
learn
and
here's how to draw a
video.
pixel to the
Yeah.
screen and here's how to read a joystick.
Yeah.
I have mixed feelings about what I have mixed feelings because is it really learning graphics or are you just like learning how to do printf debugging?
the game-like experience with the immediate feedback of drawing and hearing sounds and moving a joystick, moving your spaceship around is a huge gain or benefit to the feeling you're making progress in learning, your accomplishments. You feel like you've made something happen. Write a fucking game in the first day. Yeah, it's a huge positive feedback cycle. And you want to leverage that. You want to get people in there.
It's a
You
good
can
I
write a
I
pretty
motivation
have
good
to learn.
asteroids in a week.
Good motivation to learn trigonometry when you write something like, a ball that is bouncing off and you want to
Yeah.
compute the angle. It's actually kind of natural that you see how math is being used.
Yeah.
I had that, but I could only do printf. So it was just like a console game, like no shapes, nothing special like that.
Well, I eventually
Right.
got to curses and did console games with, 2D graphics on a
I
VT100
still
emulator. Actually, I programmed on a real VT100 too, but that was a long ass time ago.
I still never tried curses.
Just a VT100 emulator, which is just 24 by 80 screen and move your cursor around and put a thing. And if you ignored or were careful not to cause the cursor to wrap or to flow or do any of the things, you just have a low res graphics screen with characters that go around. From here now, you can do whatever you do with a low res graphics screen. You can make bounding boxes and a dungeon, a little character walks through and collects keys and food and whatever, and bouncing balls and breakout games, all because you have a 2D screen you're going to paint on. Keyboard on one end and 2D screen on the other.
Right. And I've now been developing in Python for years. And if someone told me I needed to draw a square to the screen, I would be like, hey,
Right.
AI bot, how do I draw pixels to the screen in Python?
Yeah, right. Go vibe code me this thing and then get done. Yeah, right.
Use the chart
And
drawing
what's
line.
worse is it would give me 80 lines to draw a square on the screen with a fair amount of magic in them.
Right. What happened to the easy interface?
Imagine trying to do that in, say, C and try to ask for Vulkan sample drawing a square. It's probably gonna be like thousands lines of code.
I
When the
gotta
browsers
say,
first came out with the DOM, they were mocked as a terrible way to do UI because it was such a painful experience. And now Electron is dominating everything because it's the easiest way to do UI. And it's not because it got easier. Every other system for drawing pixels on the screen got harder.
I don't have to say it, but all of you know what I use for my GUI.
This basically sounds like the stuff that DHH has been complaining about. Like he was on Lex Friedman complaining about this stuff. Like, why are we adding so much complexity to our software stacks everywhere? When I started out in 1995, if I wanted to deploy a web app, I SFTP'd my file to the server and it was running.
Yeah.
And now it takes like an hour. So he's on this like mission to like simplify deployment and stuff.
Yeah.
And it's pretty funny.
Back in my day, we
There's-
had make files. Now we have a build team that is responsible for owning the build. It
Yes.
has 4 employees.
And
Make
right. You
files?
burn umpteen billion dollars in salaries with a
Yeah.
fucking makefile would still do the job.
Yeah. Yeah.
I don't know how many
Enterprise
projects I've
quality.
seen that's pure makefile that had no M4 macros.
Oh, what? I
I've
still
seen a
use
lot of them.
makefiles to this day because they're stupidly easy and fast. You can write ugly things in makefiles, but every editor on the planet knows how to do the syntax. And if you don't do anything stupid in them, they're just like the obvious thing.
There's so many projects that you have the M4 macros.
Not me. I don't see them. I haven't run into them. But maybe we're just working in different domains.
I gotta look them up again.
This
I
is
think
this is like related to the theory that I had when I started working on the compiler like 3 years ago, that like everyone's picking up LLVM because it's the thing to pick up, and it's sort of like this like feedback loop. Maybe I'll just write my own compiler and see how hard this really is. And it was hard, but it wasn't 30 million lines of code hard.
Exactly. Yes.
And I
that's
feel like
literally
that exists in every single aspect of computer programming right now. But you know what? Vibe coding is going to fix it all for us. It'll add another layer.
I need more alcohol.
that's literally how I started Bold. Like I was telling to Cameron like how hard can an IDE be? And it turned out it's not the IDE that's hard. It's everything else that goes with it.
Right. You're still working on that?
Yeah.
Wow. That's great.
Yeah, so I started rewriting it a couple months ago. I think Cliff wanted to say something about that, but basically, I just kept on adding on it because I figure like I'm just done with this. I'll just move on to something else. And then it turned out there's nothing else I wanted to do, so I'm like, let's just clean this up and actually do a proper implementation of like these things because I expected to be done with it at some points, but turns out I want to use it.
Did you ever get to the compiler stuff that you came here starting like wanting telling us about?
So I stopped right when I had to work on the runtime or the standard library because that's going to be like another 100,000 lines of code, and I can't do 100 lines of code right now.
You need to find a targeted use case and not write a standard library with no users. Be your own user and have a use case and go use it to do something.
Well,
Like
that's the
York's not
other
on,
issue.
but his Inco project he uses to run his house's AC electronics, the heating and cooling system, the HVAC and all that. And so it's a good use case as like, here's a little small runtime system, real-time runtime system that has interrupts and it has multi-threading and has this and that. It does something useful. I use it every day. And when it breaks, I can tell. It's just
Suddenly it's
kind of the
like,
case you're
awesome.
looking for.
See, the other issue is that whenever I post about Bolin, people would just say I'm lying about the benchmarks. Like literally, no one would believe me.
It's not that I didn't believe your benchmarks. Your benchmarks were very, very, very targeted on things that I didn't care about. So having the world's
Yes.
fastest way to read and parse compile 2 billion lines of store to an array is not, in my head, a useful benchmark. It's certainly could be entirely correctly, those numbers could be entirely correct, but they're not interesting numbers to me.
They're not interesting, but I still have people tell me that I'm lying about it.
Oh, yeah, I wouldn't say you're lying about it. I'd just say they weren't interesting.
I think
Yeah.
it's easy to like get into a trap of putting out something that's like that kind of not interesting. It's correct. People like, but maybe it's hard to defend, and you end up wasting lots of time defending something that wasn't even interesting to you in the first place. Like it might be better
Yeah.
just to be like, you know what, I don't care what people think about that. I'm going to move on to the more interesting stuff.
Yeah. Yeah.
See, I
Yeah, in
think
the
that
early days of GCC, they had a bunch of really simple benchmarks. And then for a long time, their most valuable benchmark was compile the Linux kernel because it just did a little bit of everything that GCC could do.
Right. Right. A much more interesting benchmark, much bigger code base, much more variety.
I think it might be interesting to have something that people can use for websites, but also I don't know if I can talk a single JavaScript developer to not use Node.
Yeah, yeah. Pick your target here. Pick your poison. Node
Yeah,
has issues, but it's strongly entrenched. Oh, it has issues. Holy shit.
yeah, I don't know where any of my users will be coming from, so that's why I'm working on the IDE because people actually wanted it.
Yeah, I'm
Yeah.
not sure I agree with that. I think one of the beauties of the web stack is if you can open HTTPS connections and send and receive JSON objects, people don't really care what's behind it. Your API is HTTPS and JSON objects. So you can actually experiment with new languages in the web stack and on big microservice infrastructure. It would be really hard to inside one big monolithic app that's just calling from one part of the app to the other.
So that would be Node and Go developers, and I don't think I could convince code developers to either. And maybe some Java. I believe a lot of backends are Java, but I also don't think I can convince any Java people to move off of JetBrains because
Well,
JetBrains stuff is good.
maybe if you're thinking that you can't convince people who are already in love with their current language, which is virtually every programmer who uses a language, maybe you should like build stuff for building cool stuff for kids people who don't actually have a favorite language yet.
one of the most fun things I did was a couple years ago at the JCrete conference. After the conference, there was JCrete for kids, and we taught kids how to write games and the just program, but it was via writing games, and we had a little Atari-ish like-ish thing that did 80s level Atari graphics using 80s level basic like language. So it was all assessment. We had the discussion earlier about how hard is it to go write a pixel on the screen? Well, in this particular little environment, it's pretty easy. And there was an edit, compile, debug cycle that was pretty straightforward. And it was very, for me, it was very satisfying to watch some of the kids get it. Some were too young, and there was a language barrier because half of them were Greek only and whatever. And yeah, but several of the kids like snapped to it, got what was going on in the programming. And suddenly they would making modifications to the game that I hadn't thought about or thought were really cool. And they were building a real game. It was very heartening, if you will, to go
This
teach kids to program. But the
this
draw for the
remi-
kid was you're writing a game.
yeah, this reminds me of this event that a friend put on in Toronto like a few years ago that I went to. It was called Gen Art Hackathon, so generative art hackathon, and it was they structured the event with two phases. Phase one, teach everyone a 3D library. Like they had this 3D library. I think it was, I don't remember which one it was now. It was a few years ago, but um, it was, oh yeah, it was like WebGL or something. And then the second half, like make something cool. And then they had a competition for who could make the coolest thing. It was a really fun thing, and people made all sorts of like silly things, 3D graphics.
Hey, Ryan?
Yeah, so I was wondering, just maybe bring this back to compilers here for a moment. Can I share my screen? I've been working on basically like swap or like a default assignment.
Try now. Sharing.
Okay, let's see here. Uh, oh, I may have to open my web browser. Hang on a second.
If you got something you can just drop into the dock, that works too. All right. Your sound is gone. I'm thinking you did something bad, like reset your Zoom. All right, let's carry on. I think Ryan has done something to himself.
I mean, he said he had to restart Zoom to turn
Yeah.
on screen
He'll come
share.
Oh,
back.
Zoom. I heard he's going to restart. Oh, there he is.
Yeah.
I thought he was restarting his browser.
Mm.
All right, let's try again.
Mm.
Now there are two Ryans. Zoom is very confused. And I see you later, Arthur. Oh, we still have two Ryans and no comments from Ryans.
I wonder if you
I'm
keep
working on it.
Zoom in browser. That's a scary prospect.
Yeah, I've done it in the past, but I'm not hosting as Zoom in browser.
Okay, I think it works. All right. So basically I was trying to think about so what do you think about this? So I've got my built-in assignment. So I just like I don't know if this is a bad idea, but I've created like a swap operation. So basically the assignment
Show us the
is
syntax of using an assignment then. You're trying
so
to show
that
the implementation in your parser generator somewhere.
so this would be like A equals B like this, right?
Right. Okay.
And then so my thought was like, okay, for the built-in assignments, like if I have a class, I was going on this path of like, okay, I take the parameter other object by value, and then I swap them internally. So I just call the swap operator, which is this like
Double-headed arrow.
yeah, so it's that is a this, that, this, and then you know, looks like that. So that would be like A swap B. So basically what this is gonna do, so you've got your built-in operator thing, and then you've got other class type, right? And then you also have this which would be write reference to class type. And then that, hang on, let me just. So we have this. That would be like dot operator there. And then you would have this swap with
what are you trying to ask
other.
here?
So I guess is this a good like idea? I don't know. Because I'm thinking
So right, the competition to a swap operator is temp equals this equals other equals temp. That's your competition.
no, well, no, because like so this is like the default assignment. Because like what I've seen in C++ is it looks more like instead of taking the parameter by value, usually the C++ convention is like the other object is, I don't know, like const or temp or whatever, and then you copy the fields. And so you would say, this dot x equals other dot x and so on, right? And then for
That's a copy, not a swap.
right.
What?
So then you would have a second one. You'd have a second one here, right? Which would be, okay, so this is the const one. So if I'm using a temp object, what I could do is I can swap the two like this, kind of. And then, so now I have
Wait. So we're trying to define. There's two things going on here. There's a definition of what your swap operator does. It looks to me like you're trying to busy write a swap operator in terms of a
oh no,
swap
this is the
operator.
assignment. So this is the assignment operator. So this, what I'm looking at here is the built-in assignment. Swap is another thing that already exists, right?
Okay.
So swap is not relevant. Just swaps. Okay.
I actually don't understand why you want a swap operator.
Yeah,
Like most people
Aaron's
are happy with the swap function.
Aaron, put that in the code blocks because yeah, that's the option that I would use for swapping.
Yeah, well, I went with operator. You can pretend it's a function. It doesn't really matter. The important part here is the assignment. I'm not really concerned about whether swap uses an operator or whether swap uses a function. But the idea here kind of is like C++ usually looks like this, where you have the const reference to the other object, and then you have a temporary reference, which would be like double ampersand. My language has a different syntax for it, but like in C++, that would look like this, basically. So, and then you can implement this sort of temp case by swapping the contents with the other object. But what I was recognizing kind of is like, if I just take the other object by value, then if I implement both the copy constructor and the move constructor, this one sort of definition hypothetically works for both cases.
Yeah, the problem for me is that you're throwing down a swap as a thing that's interesting and not well specified in various languages, or it's well specified as broken out parts or whatever. But it sounds like you're trying to describe a problem and a solution that doesn't need swap. You happen to be using swap because it's convenient, and maybe rewrite that without using swap. Why is swap fundamental here? Why must you swap?
No,
Okay,
I
so
think what he's trying to say is that he doesn't want to implement multiple functions because in C++ you can have I'll just talk about constructors because it's just easy. You have a default constructor, you have a copy constructor, you have a constructor that you can like pass values in, and
Right.
you have a temp constructor. And a
Right.
lot of operators like equals, you have to do it for a copy and a move, which is like really annoying. And I think he's just trying to say, instead of having copy and move, you just have something else. But I thought you could just get away with just using the copy, but I don't remember 100% because I rarely ever use
yeah,
it.
so in C++ you could definitely have only the copy. So like this is the copy assignment, right? So my idea is like, instead of having copy assignment and then move assignment, there's just that like assignment. And if you pass a temporary, since the value is like passed by value, the move, like the temporary construction would happen as the constructor. So instead of having a move assignment and a move constructor, there's just the move constructor. And then it still moves the object. Because what would happen if you passed a temporary is it would call the move constructor on this other object, right? And it would create the move constructed copy, and then it will swap the contents and then call the destructor. So
I think you might just be worrying too much because I believe the optimizer would just optimize
Yes.
all your problems in a way, and you're just
no, it
concerned with
doesn't.
the
It doesn't,
optimizer not doing that.
unfortunately. So one of the things that C++ will, the compilers will not do is optimize away copies and turn them into moves. If you don't define the functions. I mean, like sometimes it can do that if it's like inlined and it can see where the allocations happen and like no allocations cross a boundary. But as a general rule of thumb, it doesn't do that.
I've seen mallocs being not called because the optimizer was able to optimize it. And I have a lot of swap functions and other functions as part of the header, so I never had that problem.
Right, but a lot of times the copy cannot be optimized away. Sometimes it can, but a lot of times it can't. And that's what I'm like it's definitely something like this is something that you need to write in your C++ if you want it to be consistently fast because the compiler figuring out that an object is temporary and getting rid of allocations is not something that regularly happens
Since you
without.
are defining the language, couldn't you define your operator assignment to be always inlined then? And then the optimizer could always optimize the
Right.
codes.
No, that's a separate problem, right? Because the problem is more like if I mean I don't really want to like this is kind of tangential like have the point of move operations versus copies and like turning copies into moves. That's kind of tangential.
Well, so what is not tangential? What is the key problem you are trying to solve?
So is like is there any problem with doing this instead of having both of these? Where this is the default, basically saying, okay, by default, if you don't create an operator equals, then or operator assign, like it'll just create this by default. Like this will be default created. Is there a problem with this that I'm not thinking of?
How does it behave on self-assignment?
It would create a copy of the object and then swap the copy with itself. So it would be an operation. So that would be like one downside, I guess. But then even then, like what you probably would end up doing is like, okay, if you know this equals other return. So that would be like if you want to handle self-assignment, you do this, right?
What does the arrow mean?
That's taking the address.
Oh, as
So
opposed to ampersand?
yeah, it's the same as ampersand, except it goes on the other side because I wanted to like, okay, this is yeah, this
Wow.
is these are opposites. Okay, this is
Yeah,
taking
reference and
pointer.
dereference.
Yeah.
Oh.
So
So you use what people have been using for 20 odd years so we can read the code directly without having to translate to language things like address of.
yeah, so well,
Right.
it depends which language you're talking about, but this is basically the C ampersand is a and then I so you would have to do this.
Right.
I guess self-assignment is the one case where this is less optimal, potentially. But
Well, it
even then,
should optimize away though. I mean, the optimizer should throw it all away.
but here's another thought. If I do it this way, there's no branch because it'll always create a copy. So in the weird case where you're assigning to yourself, which hopefully you're not doing, but if you are assigning to yourself, you still get correctness with this version. It just
Well,
wastes some cycles. So
okay.
you
So,
lose a break.
under the assumption that the optimizer fires, it throws them both away and they're all gone. And it doesn't matter what you write; they're just gone. Under the theory that the optimizer is not throwing them away because it's not getting involved somehow. As soon as you have a copy, you've got a loop over the size of the things getting copied. And the other one has an if to cut out something. I don't see the difference there.
Oh, this is just like self-assign. So if I'm assigning to myself, then this is like a kind of a race condition because I'm like editing a structure while copying from said structure. So that's like kind of a race condition in
Yeah,
some
but
cases.
it's all point-wise correct. Like in the big theory of the looping things, you're reading and writing the same structure. It's concurrent modification exception in Java. Except that down in the fine grained level, you read from X and you write to X exactly what you read. So there's not actually any issue.
It depends. Like sometimes sometimes this breaks code, sometimes it doesn't. I just
I, I would start from why would I assume it exists? The optimizer is going to clean it up. You're saying this is my default thing. It happens because user didn't write something. Okay, user didn't write something. I got a default thing. I just wanted to know that the optimizer is going to clean it up. So I don't care what the hell you write
Yeah,
there.
certainly they both could be cleaned up, but like is this approach a good default versus this, or like because like I think C++ does it pretty similar to this here. Not exactly, because instead of swap, I think they move construct each element. That's another thing that I've kind of thought about is like should should it be move constructor per element, or is
Since I don't know anything about your language, I just want to quickly ask, is it based off of C++?
yeah, like broadly, like a lot of things are similar to C++. So a lot of the lifetime semantics and scope and stuff are the same.
I just want to say that C++, even though I use it all the time and like it, it's the worst language to design after of.
To be fair, I mean, you probably know this, Ryan, but this is the so-called copy and swap idiom in C++ is a bit related because this is basically in C++, if you want to implement the assignment operator using swap, if you open that page I have just posted in the chat,
Yeah, I'm
this may
getting
look
there.
similar to what you're trying to do.
Right. So copy and swap. Yeah. So my thought is like, is there a situation where copy and swap causes a problem to be the default? And that's what I'm trying like that's what I'm trying to
What
figure out.
happens if this has more fields than that does? So this has X, Y, Z, that just has X and Y. And
Well,
now I assign
that wouldn't be possible because
that
they're
to
the same type.
this.
So this is like default class type is like the type of your object. They have to be the same. Right. So
Okay.
So what about base types? Like if you accidentally do a base type swap?
That is a good question. I haven't implemented inheritance yet, but I'm assuming what would happen is you would upcast to a reference to the base and then swap. That could be confusing, but that happens with C++'s standard swap as well. I'm not sure if there's a good way to think about that. That's a good point, but I would need to think about how to handle that a little better.
Uh, if
So
you send
if
this
you
in
scroll down to this, you can see that there are those two versions that you can write. Scroll down, you see like this, and that's kind of similar, right? But the catch here and there is going to be those two problems with this. It's going to be one of this is the always allocating, and the other
Well,
one is going to require three times the resources. I'm not sure it applies to you because you may be handling those primitives
Well,
different, but
it's not necessarily always allocating because if my default constructor creates a bunch of null pointers, right? So let's say I have a default constructor that's a bunch of null pointers, right? And then I copy construct, yes, that allocates if the type allocates because we're copying. But if it's taking a temporary, it would just move into the
yeah, but that's the
type.
point. That's the point. It's unpredictable to the programmers. So in general, in generic code, you don't know if it's going to be costly or no for any type T. It depends on how type T actually implements that and how expensive or how cheap it is to copy. But in generic context, you don't know that.
Well, that's true, but I would say that keeping the generic code, like if you're writing generic code, you shouldn't be worried about performance in that same context because you're more worried about making an algorithm that works for all cases. And if someone wants to go in and optimize their code, they can do that.
Well, yes and no, because there are cases like there is a reason stud list doesn't have all of the operations that stud vector has, and that's exactly because you don't want the generic code to use those operations that would be expensive in stud list. That wouldn't be expensive in stud vector, so stud list will not support random access iterators because you wouldn't want to throw the stud list at an algorithm that would require random access iterators and would end up working the list one by one.
Right,
So
that's fair, but I'm saying like copy is pretty reasonable. Like for the amount of algorithms that require copying, I wouldn't have a separate dot
yeah.
clone or something like that.
I mean, it's a debate with trade-offs and pros and cons on all sides. I mean, in C++ community, there's been long debate about whether you should always pass by value, and there is the argument that it rather simplifies the implementation of the code, and oftentimes the copies will be cheap or even elided. But also in a truly generic context, you may have to write all of the five versions of the constructor, destructor, whatever, and use the version for the R value reference for L value reference because it still outperforms the always pass by value version. And people kind of go back and forth on this, depending which aspects you care about more.
Yeah, I'm trying to think what are the situations where this performs better than just doing this. And I guess the case of self-assignment is one where you could potentially argue that this could be a lot slower than just doing a short circuit here and being like, I am assigning to myself, don't do anything if the object is
I
large.
think assigning to yourself is relatively rare, and if you pay that cost, you're not going to care.
Yeah, that's kind of my thoughts with this because like that's the only downside I see of doing it this way is like it will copy itself on self-assignment, but then like why are you doing self-assignment and do we really need to optimize that case if it makes the other cases faster not to do this? Because like this way will always work. And then I don't have this branch in the middle of the code.
Do you
Whereas if
plan, do you plan to have exceptions in your language? Like can assignment of the X with other X throw an exception and then prevent or cancel the second line of Y gets other Y?
so there will be exceptions at some point, but currently there aren't. So, but like this is always no except. So like assuming you can do a no except
Aha,
swap, right?
aha. Yeah, I was about to, yeah.
No
Okay.
except if swap is no except. I don't know what the syntax of that's going to be, but like no except if swap is no except. So if swap is no except, this will always cause the strong exception guarantee. This doesn't have a strong exception safety guarantee.
Yeah, and there is a very hacky version in this blog post that he does something different. Instead of swap, he's actually going to reserve and allocate uninitialized storage and do uninitialized copy to that. And he claims that's actually faster than the version with stud swap. And the only issue is that the exceptions guarantees may go away. So if you are willing to take that trade-off, then maybe that's a way to make it even faster. It's really ugly, but if you are doing this in your programming language, you just sweep it under the covers.
Let me
So
see. Do you have
take a look at this blog post. I posted this in the chat just before.
The same one I just had up a minute ago, put it back up here.
Yeah.
well, that's for vector though. That's not something I can implement as a on a generic structure, right? Because I guess like this is like just I write a class and the class has members, right? And I can't like uninitialize copy something because I
Yeah,
don't
yeah.
know if it's
But
default
but
constructible or
but
whatever.
the point is that he claims that this implementation is faster than the implementation that uses swap. He starts out with this implementation that uses swap in the beginning, like even in on the top of the screen right now, you see.
That's
The,
true. That's true because you don't run the default constructor, and that is
yeah.
valid for a vector container, but it's not necessarily valid for this case. And whether or not that is valid would depend on whether or not the type is trivially copyable or like I'm not even trivially copyable. Like, can I do placement construction? So, um, but no, this doesn't work for operator assignment because assignment assumes that the object is already constructed. Whereas if I'm constructing an object, the object is not already constructed. So it's it's doing something that's not even allowed in an assignment because we have to assume that there already exists a valid current state. So we can't do an uninitialized construction because we would not run the destructor for the state that already exists. So that's something you can do in a constructor, but you can't do that in a you can't do that in a
He is doing this in the assignment operator though. He
but
does
but yes
call the clear.
but the container has like memory that's not part of the class, right? Like it has a pointer to some memory that it allocates, right? So when you have a container, you can do that, but when you're talking about class members, by the
Yeah,
time
yeah.
you're
I
in
don't think.
operator
Yeah, I
equals,
don't think it's a universal solution. No, but like I think the point is that if there exists types like containers where this pays off, then that means this is not a generally optimal strategy. You get my point, right? So
well,
yeah,
this would
I agree that this is not universal. I'm rather showing this as a counterexample that the swap is universally optimal because it's not. because this swap strategy would be beaten for containers by
Right.
just
Okay. So what I'm talking about is like the default behavior. So these are the two default behaviors. Like
so you think you
obviously,
like synthesized compiler? What should the compiler synthesized?
right. So these are the
Right,
default.
right,
Like I'm
right,
talking
right.
about built-in assignment. Like obviously, if you have specific optimizations for your class, you don't need to use the built-in assignment. But like, what should the built-in be? Should the built-in behavior be this? If you don't specify your own overload, or should the built-in behavior be this? And I'm
Interesting.
leaning towards this.
Then the only thing I would look at is those articles that were around C++11 where people were arguing about always passing by value. Because I'm pretty sure that there's been several discussions of implementing this assignment operator also passing the other argument as value, and they would necessarily you would have to use swap to get some performance. So I'm almost sure this has been discussed. It's just on the top of my head. I cannot throw multiple links at you, but I'm almost sure when people were talking about passing by value as being the default, that was one of the points.
Yeah. So pros here. Pros. Um, strong exception safety.
But you know what? If I again, I would, given that you are implementing the language, even if it's orthogonal aspect, I would still advise to consider generating this as always inline. Because you set the rules, like it's your language, it's your compiler. So how about you set the rule that when you are synthesizing the assignment operator, you're actually always expanding this assignment, unless you are worried about the iCache costs.
I don't know what Ryan's setup is, but it's doing the echo stuff again.
Yeah, it's gonna
Oh,
say
sorry.
it's echo. Right. I'm hoping Ryan finished up what he's talking about and we'll be right. Then you can't talk.
Okay. Yeah, I think that's mostly everything. I don't know. I'll just have to look into more. But yeah, if anyone has any opinions on this and is familiar with like the C++ problems, that's kind of what I'm looking for.
Did you design your language after C++ because you want to optimize as well as C++?
Well, I want something that optimizes better than C++, and also I want to improve compile times, and I wanted something that is a little bit more deterministic and predictable. So like I've changed stuff. So for example, if I just do var x int or i32, that is a 0. It's not garbage. It's a 0. If I create a pointer and I don't give it a value, it's a 0 null pointer, right? So there are changes that I've made to like reduce bugs, because like what I'm trying to improve is like velocity, right? I want to spend more time making programs that are correct and less time debugging.
Ironically, you're doing what I did, except the way I did it was not doing what C++ does, because it's so much easier to not do it that way.
Sorry.
You know what? I should just send you a link to my language so you can see. But basically, I don't have pointers and certain other things. Well, okay, I have pointers, but it's a long story. But I made it. I made it less. I have the language is like smaller in scope, and it's more high level, and it's much easier to optimize. And I got it running faster than C++ in a few spaces. That's because I was able to change. I didn't have to use C++'s ABI. So I think right now that's the majority of my wins. But I still want to improve the memory optimization.
Yeah,
That's another long story I don't want to get into.
I've seen that problem as well in C++. That's why I swapped out the constructor destructor order to be or from caller to callee. So I did that as well.
All right, let's wrap it up. I got things I have
But
to
one
do.
thing kind of tying those two threads together of the debugging experience of Cliff and the deterministic goal of Ryan, I would actually really suggest considering the designing this compiler that it so that it always inlines the operator assignment, because that will kind of solve this problem. Because then even in the debug mode, no one would have to step through this assignment operator. because it would be inline. So maybe there is the case to always do some optimizations, even at proverbial or zero. And then it kind of solves some of the problems away because you always have optimizer acting on your assignment operator. Maybe some things really should be treated as built-in things at the language level and not have the optimization stand off from them, even at zero is what I'm saying.
I
Right.
got a question, but this could be for next time. It's
Fire
how
it
do you
away.
make a language popular? Because we started discussing that a little bit, but yeah, I thought like the standard library would just make a language popular, but I'm not 100% sure anymore.
No, you gotta have a person who wants to use it, which you have to supply something that they can't get elsewhere. And then
So just having a good standard library, like I guess Go has a pretty good one. That's not good
right.
enough.
It's not because when Go started, the reason it got going is because Google pushes big. Okay. And they have some desire to enable a lot of people and they have big dollars, so they know they're going to use standard library and they go there. But if you go pick a different language, it becomes popular or doesn't, whatever. The first thing happens is I wrote it for reasons, and somebody else comes along and says I use it because reasons. And then if I want more and more and more people, I start rounding out the libraries and more becomes more and more convenient to use. But the starting point is always I'm using Haskell for reasons. I'm using Pony because I can do something to high frequency trading. I'm using Haskell as I want to do functional programming. I'm using X because whatever. There's some very targeted reason. Some set of users starts using whatever a language is and they code to it or they get somebody who's going to code to it and the two or three of them get together and deal with it. Once you have a corpus of I'm a consumer and I'm a producer of the language, Levo's a producer, somebody's a consumer. Now you begin rounding out, oh, the debug experience sucks because of this. Oh, I have to write all these things, so I'm going to go write them by hand. But boy, standard library would be nice. But you don't, that's how you grow. But you don't start with a standard language. A standard library is too big. Unless you're Google, you're not going to write a standard library up front.
Yeah, exactly why I stopped. But it also sounds like I have to, it's not the language. I have to get like a really good framework that people want to
You
use.
have to get a consumer, and the consumer will drive you. So
I was
who's the consumer?
I was hoping just compiling millions of lines would be good enough, but no.
I'm writing, I have all kind of languages that have fast compile speed, C++ not being one of them. That gives me fast edit, compile, debug turnaround times, including Python with the REPL directly. Java's pretty good on that front. So that just faster compile times isn't itself a driving factor.
I'm just kidding here, but I think what a great idea would be is to take whatever I make as a GUI library and then make that a framework that I can give out to people.
Again,
And
you
they
want
don't
a
have to use
consumer.
Electron.
You have a GUI library. Get somebody to say, this lets me write GUIs better, faster, bigger, whatever. Now your competition's not a compiler, but it's Qt or whatever.
Yeah.
You need a consumer. You need to find somebody who says, Levo, you have this cool thing. I'm going to use it, but make it better. And then, it'll drive expansion. All right.
Yeah, that's all for me.
Yeah, I write simple because my consumer is a hypothetical compiler learner student. And then I've had, 20 reliable students. So I'm happy with what came out of that. It's not taking over the world. I didn't expect it to. But,
I heard it mentioned at a conference recently. I can give you a link later, but
yeah.
yeah, I was just surprisingly
Yeah,
see.
somebody talked about simple as driving them to using Sea of Nodes for whatever project they were doing. And there was a video that came around recently with a guy on stage talking about it. Okay. Okay, I'm gonna call it. I have things to go do, but it's been fun. I'm back from
All right.
Burning Man.
All right. See y'all.
Sometime I can tell you all the Burning Man stories, but another time. All right. Bye-bye.
Bye.